And here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So today, eventually we're going to go on to section 7.6, but first of all, we've got some questions from you folks that you emailed me. So first of all, we're going to look, this is in section 7.5, and this is problem number 17. It says, simplify the complex fraction. Okay. And the fraction is, let's see here, b squared minus 100 over 30a squared, and that whole thing over 9b minus 90 over 10a. Okay, I'm going to make this one a little bit longer there. So I need to find the least common denominator of 30a squared and 10a. Well, that would be 30a squared. So I'm going to multiply 30a squared on top, 30a squared on the bottom. Any questions about how I did that or why I did that? Okay, so now taking this times this, the 30a squareds would reduce out, leaving us with b squared minus 100 in the numerator. Taking this times this, 30 over 10 is 3, and a squared over a is a. So I've got 3a times 9b minus 90. Okay, so now I have a simple fraction, but let's see what else we can do with that. The numerator of this new fraction is the difference of two squares, b plus 10, b minus 10. The denominator, we've already got a 3a that's factored out, but we could also take out an additional 9 and get b minus 10. So that would give me b plus 10 times b minus 10 over, I'm going to take 3a times 9, this is a 9, and get 27a times b minus 10. All right. So now the common, let's see here, the common factor that can come out is that. So my final answer is b plus 10 over 27a. And there you have it. Any questions about that one? Okay, now we're going to take a look at problem number 21. Same section. Again, simplify the complex fraction. We have the following: 2 divided by x cubed minus 2 over x, all divided by 4 over x plus 8 over x squared. Well, our denominators are x cubed, x, and x squared. So the least common denominator would be x cubed. And then we're going to distribute that on top and on the bottom. So I'm going to take x cubed times 2 over x cubed. So I've got, let's see here, 2 over x cubed times x cubed over 1 is going to reduce down to 2. Okay. Minus 2 over x times x cubed over 1. X cubed over x would be x squared, so we get minus 2x squared. So that's our entire new numerator. Down below here, we've got 4 over x times x cubed over 1, which reduces down to 4x squared, and then plus 8 over x squared times x cubed over 1. X cubed over x squared is x, so I get plus 8. So now I have a simple fraction, but let's see here. We can take a 2 out of the top and a 4 out of the bottom. Let's see, x squared plus 2. We can factor the numerator further because 1 minus x squared would be the difference of two squares, 1 plus x, 1 minus x. However, we can't do anything more with the bottom. So all we can reduce out is the 2 over the 4 is 1 over 2. So on the top, I've got 1 minus x squared, and the bottom I've got 2 times the quantity x squared plus 2, okay? And, or you could say what, 1 minus x squared over 2x squared plus 4. Wait a second here. Somehow I've lost an x. So let's see. Oh, right here, folks. I didn't bring that x over here. Yeah, that changes things. My bad, my bad. I didn't bring down something that I had left over. So let's go back and let's make sure we've got this correct. Let's see here. Not a good way to start a Monday, huh? Okay, so let's see. Right here. So I can take a 2 out of the top and get 1 minus x squared. I can take a 4x out of the bottom and get an x plus 2, right? All I can do then is get rid of that. So I've got 1 minus x squared over 2x times x plus 2, which is 1 minus x squared over 2x squared plus 4x. There we go. So yeah, as I have shown here, you got to be really careful when you cross things out that you can read what's left over. I missed that x. Okay, now I'm going to go back to another student's questions. So give me a minute here. Let's see. There and here. There. And now. Okay. We're still in section 7.5, and this is problem number 19. Simplify the complex fraction by using the LCD. So we're doing the same thing here. Let's see if I can redeem myself. So we've got m over n plus n over m. All of that in the numerator. M over n minus n over m in the denominator. Okay, so our little denominators are n, m, n, and m. So the LCD would be m times n. So m times n over 1, m times n over 1. Okay, so distributing, we're going to take m over n times mn over 1. The n's reduce out, and we're left with m squared. Okay? And here, plus n over m times mn over 1. The m's reduce out, and we're left with plus n squared. In the denominator, we've got m over n times mn over 1. The n's go, and we've got m squared. And then minus n over m times mn over 1. So we get minus n squared. Well, The numerator doesn't factor. The denominator is the difference of two squares, but factoring that, we don't get any common factor in the top and the bottom, so I'm just going to go back and leave it as that. M squared plus n squared over m squared minus n squared. Any questions on that problem? Okay, we're going to go on and take a look at a problem number 21. I did a 21, but I think this one is a little bit different. Let's see. Look at what the 21 was that I did earlier. Yeah, just a little bit different. Same idea. So here's 21. It says 3 over x squared, over x cubed, my bad. X cubed minus 3 over x, all over 9 over x plus 6 over x squared. So here, our least common denominator is going to be x cubed. Okay. So we're going to take what? 3 over x cubed times x cubed over 1, which is 3. Minus 3 over x times x cubed over 1, which is 3x squared. In the denominator, we're going to take 9 over x times x cubed over 1, which is 9x squared, plus 6 over x squared times x cubed over 1, x cubed over x squared is x, so plus 6x. I can now factor a 3 out of the numerator and a 3x out of the denominator, and then I can reduce out the 3's. The top is the difference of two squares, but the bottom doesn't factor, so I'm not going to be able to take anything else out. I'm just going to multiply it all back together, and we get that. Any questions there before we go on? All right, now we're going to take a look at problem number 22. We're still in 7.5. Simplify the complex fraction. We have 4 in the numerator, b over a minus a over b in the denominator. Well, the implied denominator of the numerator would be just a little 1 underneath that 4, okay? So my LCD is going to be 1 times a times b, or just ab. So on top, I'm going to get 4 times ab, which is 4ab. On the bottom, I'm going to get b over a times ab over 1. The a's go, and I'm left with b squared, minus a over b times ab over 1. The b's go, and I'm left with a squared. Now, b squared minus a squared could be written as b plus a times b minus a, but that doesn't give us a common factor with the numerator, so that could be your final answer, or I suppose you could leave it factored out like that. Okay, we've got one more to look at here. Same section. This is problem number 23. Again, simplify the complex fraction. We have 6 minus 6 over x plus 1. All of that divided by 6 plus 6 over x plus 1. All right, again, there's implied 1s below the 6's. So our LCD, let's see, our denominators are 1, x plus 1, 1, and x plus 1. So the LCD is just x plus 1. So I'm going to multiply the numerator and the denominator by x plus 1. So let's see here. We've got 6 over 1 times x plus 1 over 1, okay, which would be what? 6x plus 6, distributing the 6, and then minus 6 over x plus 1 times x plus 1 over 1. The x plus 1's go, and we have minus 6. Down in the denominator, we have 6 over 1 times x plus 1 over 1. So again, we get 6x plus 6, and then plus 6 over x plus 1 times x plus 1 over 1, which gives us 6. So in the numerator, we get 6x. In the denominator, we get 6x plus 12. But we could factor a 6 out of the bottom and then reduce out a 6. So we end up with x over x plus 2. Kind of tricky there. I see I'm looking at the student's answer, and they stopped there. So they had it right up to that point, but they needed to factor a 6 out and then reduce it out. Okay, those are the questions that students sent in. Does anybody have any other questions before we go on to section 7.6? All righty, then we shall proceed with section 7.6. You can multiply or divide both sides of an equation by the same non-zero number. So you can multiply both sides by anything but 0. You can divide both sides by anything but 0. But we got to be careful that we don't multiply or divide both sides by 0. Now, let's take a look at some examples of equations that have variables, or I should say fractions. Let's see here. We've got 2/3 equals 1/2 plus x over 6. So we want to solve this equation for x. But the first thing we're going to do is clear the fractions. And the way we're going to do that, first of all, we're going to find the LCD. So let's see, in this case, the LCD of 3, 2, and 6 would be 6. Then we're going to multiply both sides of the equation by 6. In doing so, it will wipe out all the denominators. 6 times 2/3 equals 6 times 1/2 plus 6 times x over 6. So distributing the 6. On the left side, 6 over 3 is 2 over 1, so I have 4 equals. 6 times 1/2 reduces to 3 over 1, so 3 plus x. So I now have created an equivalent equation, but the fractions or the denominators are gone, I should say. So the fractions are gone as well. All right, so now I'm going to subtract 3 from both sides, x equals 1. Let's check our work to see if that's correct. 2/3 equals 1/2 plus 1 over 6. Oh, let's see. So here again, we could clear the fractions, multiply both sides by 6, and we get what? 12/3 is 4 equals 3 plus 1, 4 equals 4. So the solution checks. Any questions about that particular problem? We're going to take that same idea and just get more and more complicated problems. We'll have an equation with fractions. We'll find the least common denominator of the entire equation. We'll multiply both sides by the least common denominator. We'll reduce out all the fractions, all the denominators, solve the equation, check our work. Okay, let's see here. How about this one? 3 over 4h plus 2 over h equals 1. So the denominators are 4h and h, and then an implied one on the last number. So the LCD is going to be 4h. As I'm doing this, if you have any questions about where I found the LCD, please let me know. I'll go back and go through the steps. So I'm going to multiply both sides of the equation by 4h. On the left, I get 4h times 3 over 4h plus 4h times 2 over h equals 1 times 4h. So reducing out the 4h's, I get 3 plus h's go away, 8 equals 4h. 11 equals 4h. Divide both sides by 4, and h equals 11/4. Any questions on that one? All right. Let's say we've got z minus 16 over z equals 6. So this is like there's an implied one there, an implied one there. So the least common denominator is just z. Z times 1, okay? So I'm going to multiply both sides of the equation by z, or z over 1. Distributing the z on the left side, z over 1 times z over 1 minus z over 1 times 16 over z equals 6 over 1 times z over 1. Going through and simplifying each product, we get z squared minus 16 equals 6z. I have a second degree equation. So I'm going to put it in standard form. I'm going to set it equal to 0, subtract 6z from both sides. Z squared minus 6z minus 16 equals 0. Remember this from chapter 6, not all that long ago? I can factor this. Let's see here. How about a minus 8 and a plus 2? So if z minus 8 equals 0, z plus 2 equals 0, add 8 to both sides, z equals 8. Subtract 2 from both sides, z equals -2. So I get 8 and -2. That's my two solutions. Any questions before we go on? All right, we'll continue then. Let's see here. Let's take a look at this equation. 3 over y minus 2 equals 3 over y minus 2 plus 1. Okay? There's an implied 1 in the denominator below the 1 on top. So my denominators are y minus 2, and 1. So my least common denominator would just be y minus 2. Okay? So on the left side, I'm going to multiply by y minus 2. And on the right side, I'm going to multiply by y minus 2. Okay. So over here, let's see. Y minus 2 times 3 over y minus 2 would just be 3. Here, I've got 3 over y minus 2 times y minus 2 over 1, which would be 3. And then plus 1 over 1 times y minus 2 over 1 is just going to be what? Plus y minus 2. So I get 3 equals y plus 1. I subtract 1 from both sides and I get y equals 2. Any questions? There's an important step that I've deliberately skipped after the first problem. Let's go back up here. Let's see, what did I do? That was finding least common denominator. Here. I got an answer and I checked my work, okay? And then I just sort of, I got lazy and I didn't check my work there, and I didn't check my work there, and I didn't check my work there. Shame on me, because on this problem, if we take y equals 2 and we plug it back into the original equation, if y equals 2, what does that denominator become? What's 2 minus 2? 0. Same thing with that one. Well, if we get a solution that makes the denominator of any fraction in the original equation 0, remember dividing by 0 is undefined, so this is no solution. Now, this gets a little tricky because I believe what WebAssign does is they'll have you come up with this answer, and then, so y equals 2, and then you'll say that there's no solution, and it will also say that 2 is what they call extraneous. I don't know if you can see that, extraneous. Let me write that on the next page here. Extraneous. So what that means is it's a solution that doesn't work. Now, you might be saying, well, did I mess up? Because how did I get an answer, but the answer didn't work? Well, another thing that I said earlier was I said you could multiply both sides of the equation by the same non-zero number. Well, here's the problem. I multiplied both sides by y minus 2. But if y equals 2, then y minus 2 is 2 minus 2 is 0. So I didn't know it at the time, but I multiplied both sides of the equation by 0. So I broke the rules unknowingly. That's why I got an answer, but the answer doesn't work. So the bottom line of all this stuff is check your work. Now, if you're one of those lazy people that doesn't want to check their work, you better at least check it in the denominators to make sure it doesn't turn any denominator into 0. Okay. If you're going to fully check your work, you plug it in every place, you go through and simplify it all down and see that you get a true statement. But if you're going to do it the lazy way, you at least make sure none of the denominators turn into 0. Okay. All right. Going on. Let's see here. We have x plus 6 over x plus 4 plus 1 over x squared plus x minus 12 equals 1. Now, to find the least common denominator, we're going to have to do some factoring. The first fraction, its denominator is already factored as much as it can be. However, the second fraction can be factored into x plus 4 times x minus 3. So my denominators are x plus 4 for the first fraction, x plus 4 times x minus 3 for the second fraction, and an implied 1 in the denominator of the third fraction. So my LCD is going to be x plus 4 times x plus 3. All of that. Any questions about that? So now I'm going to multiply both sides of the equation by the LCD. Let's see. Actually, hang on here. What I want to do is I want to put it over there to start with. And then over here, x plus 4 x plus 3 over 1. Okay, now I'm going to distribute the x plus 4 times x plus 3 here and then here. But doing it this first place, that gives me x plus 4 times x plus 3 all over 1 times x plus 6 over x plus 4. That's this times this. Now taking it times this, we get plus x plus 4 times x plus 3 over 1 times 1 over x plus 4 times x. Oh, it is a minus, isn't it? Yeah, I'm just having a great day today. This is supposed to be, yeah. I factored that and then somehow I changed it. Oh, my bad, my bad, my bad. Okay, let's see, that's a minus, that's minus, that's minus. My apologies. Guess I'm having a Monday. Okay, I think I've got that all straight. So somehow I turned my minus into a plus, and that's going to make a big difference. All right, equals 1 times x plus 4 x minus 3 over 1. Okay, we good? Hopefully. So now, simplifying this whole mess, the x plus 4's go, and I have x minus 3 times x plus 6. Simplifying all of this, everything goes except I just have plus 1. And over here, I've got x plus 4 times x minus 3. But I've gotten rid of all the fractions. Okay, so now x squared plus 6x minus 3x minus 18 plus 1 equals x squared minus 3x plus 4x minus 12. Combining like terms, I get x squared plus 3x minus 17 equals x squared plus x minus 12. I'm going to take this and copy it on the next page. So x squared plus 3x minus 17, x squared plus 3x minus 17 equals x squared plus x minus 12. Now, this is a second degree equation, so it looks like I should put everything on the one side of the equation, set equal to 0 on the other side. Okay. So I'm going to subtract x squared from both sides. But what I discover is when I do that, now it's no longer a second degree equation. So my strategy is going to change. I'm going to put x on the left and the constants on the right. So I'm going to subtract x from both sides, add 17 to both sides, divide by 2, and I get x equals 5/2. Now, let's go in and check our work. Okay, 5/2. Now, should I do it fully and check it everywhere, or just check it in the denominator? You tell me what you want me to do. No one's going to respond. Fine, I'll just check it in the denominator then. I'll take the lazy way out. Okay, let's see. Right here, my denominators, I've got an x plus 4, an x plus 4, and an x minus 3. Well, the denominator of x plus 4, if x was negative 4, you'd have 0. X is not, it's what, 5/2. Same thing here. Here, x minus 3, if x was 3, the denominator would be 0. So for this problem, x can't be negative 4 and x can't be 3, but there shouldn't be any problem with x being 5/2. So there we have that. Okay, Now we're going to look at solving some formulas for a given variable. Let's take a look at this. Let's see. I've got t equals 3r over m minus n. Keep in mind when you have formulas, let's say you have a uppercase r and you have a lowercase r in the same formula, they aren't the same variable, so don't combine those. Capital R's, lowercase r's, different, because you might have a formula with two different things that have the same first letters, but one of them's large, capital, one of them's lowercase. All right, we're supposed to solve for r, so solve for r. First thing I'm going to do is clear the fractions. So I'm going to multiply both sides by m minus n. Okay, on the left I have m minus n times t, and on the right I have 3r. I could come back and divide by 3. R equals m minus n all times t all over 3. Any questions on that one? All right. Let's say we've got 2 divided by c plus 2 divided by d equals 1 divided by h, and we want to solve for c. C is in the denominator, so if I get rid of the 2 on top and I have 1 over c, that still isn't solving for c. That would be 1 divided by c. So I need to get c up on top. What I'm going to do, I'm going to multiply both sides of the equation by the LCD, which in this case is c times d times h. Okay? So c times d times h, c times d times h. Over here, I get c times d times h times 2 over c plus c times d times h times 2 over d equals 1 over h times c times d times h. Okay, now going back, let's see. I can reduce out and get 2dh plus, the d's go, 2ch equals, the h's go, cd. Now keep in mind, I'm trying to solve for c. I've got 3 terms in my equation, 2dh, 2ch, cd. Again, I'm trying to solve for c. What I need to do is get all the terms that contain c on one side of the equation. I'm going to put them on the right side. So what I'm going to do is I'm going to subtract 2ch from both sides of the equation. Now I have 2dh equals cd minus 2ch. Now, what's going to happen next is, I don't know if you want to call it a trick, but it's a step that comes up in math a lot. So you're going to want to remember this. To get the c by itself, I'm going to factor the c out of both of these terms. What that allows me to do is now I can come in and divide both sides by d minus 2h, and I've got c by itself. So 2dh over d minus 2h equals c. So what did I do? I multiplied everybody by the least common denominator to clear the fractions. I got all the terms that contained the variable c on one side of the equation. Then I factored the c out so I could divide both sides by what was left. All righty. Let's take a look at another problem. Let's see. F over m equals a. Solve for f. Well, f is on top. All I need to do is get rid of the m in the denominator. So I'll multiply both sides by m. and I get F equals AM. That one was pretty nice compared to the last one. Let's see here. How about this one? Let's see. 1 over A minus 1 over B equals 1. Solve for B. So I'm going to multiply both sides by the least common denominator. So the LCD is AB. So AB. AB. Distribute, I get AB times 1 over A minus AB times 1 over B equals 1 times AB. AB times 1 over A is just B. AB times 1 over B is just A, so I get B minus A equals AB. Well, again, I'm trying to solve for B. So get all the terms with B on one side. I'm going to subtract B, so I get negative A equals AB minus B. Then I'm going to factor a B out, and I get A minus 1. Divide both sides by A minus 1, and I get negative A over A minus 1 equals B. A. So that's very similar to when I did a couple steps ago. Let's see here. How about this one? 2 over x plus 9 equals 11. To solve for x, I'm going to multiply both sides by the LCD, which is just x. So multiply here and here. So I get x times 2 over x plus x times 9 equals 11 times x. So x times 2 over x, I get 2 plus 9x equals 11x. So we're going to subtract 9x from both sides, divide by 2, and x equals 1. Let's check it. If x is 1, we get 2 over 1 plus 9 equals 11. 2 plus 9 equals 11. 11 equals 11. Well, that one was pretty nice. Okay. I knew there was something more important I needed to talk about. A over 3 plus 3/5 plus A over 15. And then A over 3 plus 3/5 equals A over 15. Can anybody tell me what this is? Anybody?
Is it a divider?
No, this is the sound of one hand clapping. Can you hear it? How about this? Can you hear this?
Yes.
That's the sound of two hands clapping. Well, this first thing right here is kind of like this. The second thing is like that. Can anybody guess what I'm trying to get at? What's the difference between these two problems?
One's being added and the one's being equal to, so both sides will be giving a two different solution.
Yeah. So the first problem, A over 3 plus 3 over 5 plus A over 15, it's just like there's one side of an equation. It's not an equation. You can't clear the fractions. You can't multiply both sides by 15 because you don't have both sides. Okay. The second one, A over 3 plus 3 over 5 equals A over 15. That is an equation. You have both sides, so you can multiply both sides by 15 to clear the fractions. Okay, so this first one, all you can do is build everything. This is already there. So this is going to be what? 5 over 5. So 5a and 3 over 3 plus 9. So you're going to get 6a plus 9 over 15, which is 3 times 2a plus 3 over 15. 3 over 15 is 1 over 5. So you end up with 2a plus 3 over 5. And I know I went through that kind of quickly, but the point was I couldn't clear the fractions. I can't get rid of them. I'm just adding or subtracting terms. It's not an equation. Now, the second scenario is an equation. Here, I can multiply both sides by 15 because I have both sides. So I get 15 times a over 3 plus 15 times 3/5 equals 15 times a over 15. Going through and reducing, 15 over 3 is 5, I get 5a. 15 over 5 is 3 plus 9. 15 over 15 is 1 times a. Let's see here. So I'm going to subtract a and get 4a plus 9 equals 0. And subtract 9 from both sides. 4a equals -9. Divide by 4a equals -9/4. So very different. Okay. Again, I want to emphasize, if you don't have an equation, you can't clear the fractions. Because so many times I'll see students take a problem like this and they'll multiply by 15. But you can't take, if you could just take something and multiply by 15, I could pull $1 out of my wallet and say, oh, multiply by 15, it's $15. That would be nice. You've got to have something equal to something else. Then you multiply both sides by that same non-zero number. Okay, anyway, happy Monday. This was section 7.6. I will be back at 1:15 for an office hour should you have any questions. Other than that,